Good morning, everyone. Tom Gunthorpe from AgriScan. The value proposition that I'm presenting today is ultra-high frequency radio frequency identification for livestock. Just to be clear, UHF RFID sits just above 900 megahertz, where the current technology is down 134 kilohertz. So they won't ever interfere with each other. Why UHF RFID? UHF RFID has been uptaken by many other industries since at an exponential rate since 2012. That significant investment is driving the price down of this technology and will continue to do so. And the reason they're looking at this technology is the high read speeds, the ability to read all tags in the field at the same time, and obviously lower cost. Moving more to the application at hand here, this gives us the ability to move from a mob-based averages management system or gut feel to a quantitative measurement system where we can manage the animals individually. For example, we might want to draft off the lower performing animals, or sometimes just taking the high or the top animals off the top, which could be bullies, taking them out of the system, let the low ones come up. The tags that we offer are in the same form factor that we've been using for the last 20 odd years. So when it comes to application, people are familiar with what we're using. This is the first install scenario we did at Karwoola. 50 rams were tagged with the UHF tags, and we presented this yesterday at the open day, where we ran the sheep through the Tapari handler, and essentially all I had done is substituted the UHF reader to read the tags, and we Bluetoothed across the Tapari skull head. From that point, everything was just transparent. Record the weights and so on. Typical data set. Here we're recording the weight. We're calculating the average weight gain or loss against that individual animal. It's time-stamped. So if we will pivot that data, we can very easily see how the performance of that whole mob is going. The ones losing weight, we need to do something about those. And the ones gaining weight, well, we might take them off the feed and feed them, look after them separately. Once we've got the pivot data, we've got further decision points that we can use where we can draft against a weight gain or loss worse than just weight alone. This is the second install scenario we did at Karwoola. It was a bit of an experiment and a bit of a proof of concept, if you like. But what we were able to do here was prove that we could capture tag data from multiple animals at the same time and report that data back to the cloud. We found a few interesting things, and Darren mentioned this yesterday, where they found that the sheep were favouring one side of the trough, and that was because there's a great big puddle on the other side and they didn't want to get their feet wet. So just from just this little sensor, we can pick up some animal behaviour. But having done that, this setup lends itself to other applications like walkover weighing, because we could measure multiple animals at the same time, maternal pairing, or time at feed trough. So this lets us capture data where we can start to learn about the social interaction that animals have, and it's quite amazing what goes on. This is just a very simple data set that came through from the stream, but Pear Tree and others have dashboarded this data that I may show later on. Learnings. This is not just about this particular install, but generally what I've experienced through this whole development process with this technology. But every installation is different. You turn up with an idea on how you're going to put it together, and it's all different. Anyway, you've got to work with that. Requirements and expectations have been varying greatly across the board. Technology and innovation is advancing at a faster pace than the average learning capacity in the marketplace. I think a lot of people have been experiencing that, but let's keep pushing it forward. And this last one, technology, the speed of technology change means that regulation and industry standards need to continuously improve to keep up. This has been my greatest challenge with this product, not the technical stuff, it's everything else. And I can't see the bottom of the slide here, but its collaboration's been very, very positive. Future developments. I have grand plans to have the reader itself become a smart edge device. It's already Amazon Web Services ready so that we can send data straight to the cloud. For example, we could send georeferenced data into the NLS database. We could send data into the AgriWeb backend. They're developing some great stuff with individual animal management, but how are we going to get the data in there, boys? So we can inject the data straight into the database. Similarly, moving all the functionality out of the scale heads into the reader itself. It's already got a website built in, so it's just a matter of expanding that. Compete and collaborate. Thanks, Sean. So what we're presenting here is a table of cost and benefit across the tag range. And there's just one anomaly here, and that is that the UHF technology has a higher performance at a lower cost than the current technology. And then collaborate. This was the fun part of the whole program, we're working with the other teams. What we've done though, we've been able to create a tech ecosystem for the benefit of the farmers. And you can see there the data flowing through from the scanners, either to the Tapari via Bluetooth or via the network systems up to the cloud systems for presentation. Thank you.